I made this prop for Halloween 2017 as part of my Mad Doctor costume. Along with the spinning blade, it also smokes, lights up, and plays sound. The model was designed in Fusion 360. My goal was to make the prop look hefty, like it could have been a real woodworking tool at one point, but also like it's seen better days and it's kind of struggling to keep up. The oversized motor cover and 20-volt label on the fake battery in the back helped to convey this message. The actual prop runs on just 9.6 volts. It went through quite a few iterations and lots of test prints before I got the shape and weight that I wanted. The saw blade is made of simple craft foam, so it can't hurt anyone if they get too close. The motor is a 1000 RPM 6-volt geared DC motor I bought off AliExpress and ended up being majorly underpowered. I did leave an option on the PCB to run the motor off of 6 or 12 volts though, so my hope is to replace this motor in the future with a bigger 12-volt motor. As a result of this undersized motor, I had to try to save as much weight as possible on the blade, so I made the middle a thin, hollowed-out printed piece, leaving only the exposed edge as the foam blade. This ended up working out just fine, although I'd still like to eventually replace it with a heavier motor. The fog effect is achieved using a cheap vape pen and air pump, also off of AliExpress. The vape pen and air pump are connected via a few custom fittings. I had trouble soldering to the vape pen even after removing the outer chrome layer with a Dremel tool, so I developed a connector that allows me to get connection with the center pin of the vape while still allowing air through. It worked well, but isn't the most robust solution, so I have a few other parts in the mail right now that I'm going to continue to experiment with to find a better solution. They nestle into the core of the prop with really no room to spare at all. The flickering lights combine with the fog effect to help sell the effect that the power tool has seen better days and is being pushed to its limits. And this is where I ran into my first issue with this prop. The motor cover contains 2 independent LEDs designed to simulate sparking. The Arduino Nano only has 3 timers though, and 2 of them are already being used by the audio system and the front-facing red LEDs. That leaves only 1 timer for the 2 spark LEDs. I may have been able to use the 1 timer to do a soft PWM, but I didn't have time before Halloween to figure it out, so I ended up running with just 1 spark LED. The audio was a last-minute addition when my wife saw an early version of the prop and asked why I wasn't making a sound. I had to admit that if the effect was meant to convey a powerful saw, that silence wasn't really selling that effect. So I went back to the drawing board and crammed a speaker into the lid. I also added a super basic amplifier to the PCB. It didn't need to sound amazing because it was just a high-pitched saw noise. This let me get away with a very small speaker and very simple amplifier. Early on in the prop's development, I used off-the-shelf boards I had bought off AliExpress. I quickly ran into issues with them though. The first being that I was completely out of room in the prop. Relays were totally overkill for the power I was running and were taking up too much room. MOSFETs work just as well in this situation, and I can fit them in a much smaller space even with their heat sinks. I had been experimenting with designing my own PCB, so I put together the Schematic and EasyEDA, put together a board layout, and received these in the mail just a couple weeks later. And given that this was only the second PCB I've ever designed, I'm pretty happy with how they worked out. That's not to say that they worked perfectly. Thankfully, I noticed before applying power that the MOSFET had 2 pins flipped around. It turns out this was an issue in the template provided by EasyEDA. So lesson learned there, always check the pinouts, even on stock templates. I notified EasyEDA and they fixed it since then, but I wasn't going to order a whole new set of boards so close before Halloween, so I carefully flipped the pins on the MOSFET and installed them. The audio amplifier is where I ran into the other issue. The circuit is a standard LM386 audio amplifier, which is about as basic of an amplifier as you can create, but the audio was totally unusable once I soldered everything up. After a bit of debugging of the circuit, I ended up having to take it to an electronics expert, who quickly diagnosed that the power supply to the chip was oscillating. Apparently I wasn't careful enough with laying out my power supply traces, so that's lesson learned number 2. The addition of a 470 microfarad capacitor across the incoming power stabilized it and produced usable audio. If you'd like to take a closer look at all this or try making one yourself, the object files are available on Thingiverse, the source code is on Github, and the schematic and PCB are available on EasyEDA. Links are below in the description, and thanks for watching.